Good morning, students. Today we're going to discuss about voltage regulator. Let us see in detail. Okay, so you all know about Thomas Alva Edison. So in 1883, he's just invented a bulb, and it's a brilliant idea. And the DC generation of the day were widely inconsistent. And 1 minute Morgan getting a 100 volt, and the bulbs is dim and yellow. The next time it is 120 volt, so it is very powerful. So the glass everyone is expenses and had also broken immediately. Example, whenever you get a voltage the correct level, there won't be any problem. The voltage fluctuation is very low, which means your components or whatever instruments use it get affected. When it is very high, what automatically it will happen, the damage will happen. So if you take a glass bulb, if it get a higher voltage, what will happen, it will just burst out. So in order to prevent that, the power source should not be messy, and also the load should be picky. So in order to maintain the circuit or whatever the electrical component safety, we have to maintain the voltage without fluctuation. So voltage regulation is mandatory. So let us see what is voltage regulation. So a circuit that maintain a constant output voltage regards the any changes in output or also load current. For example, if input is 5 to 12 volt, messy and noisy and also fluctuation. So the regulator not on my watch. So the output will be around 3.3 volt. And let us see the two main families of this voltage regulator. That is, one is your linear, another one is your switching. So linear is something that acts like a small resistor and burns excessive voltage as heat, whereas switch regulator is rapidly switching on and off, and also it uses an indicator to store energy. These are the main function of the voltage regulator, that is linear mode power supply and switching mode power supply. Let us see some key specification, which means dropout voltage, how much higher the voltage input must be equal to the voltage output. And also line regulation should be constant, it should not jumps between 7 to 12 volt, and load regulation that also should be very constant. So let us see the content of today's class about what is voltage regulation and what are this formula and effects and types, and also working and properties and characteristics and applications. So you all, what we discussed in previous is that voltage regulation is a process of controlling and adjusting the output voltage, even whereas there is any change in input that should not be affect the output of the system, and in which the specific range is typically narrow tolerance. And here the electrical power transformer is an open circuit, and also see, this is an open circuit, and also there is no need of load that is connected to the secondary terminal of the secondary terminal voltage that should be equal to the secondary induced voltage. For example, the secondary terminal of the transformer rated to I2 flows through the secondary circuit, and the voltage becomes a factor. So in this scenario where I2 represents the secondary current, and also Z2 represents the impedance of the transformer. Next, what is voltage? Voltage is something that are fundamental electrical components, which we saw in previous classes, that it represents the electrical potential difference between 2 points. The voltage is responsible for pushing the electrical charges through the conductor, whereas so that the component is able to give energy. Next, let us see the effects of voltage regulations: solidness, dependability, and security and effectiveness. These are the most effects of voltage regulation. So we have to maintain stability, and we have to eradicate the ripples. Next, these are the types of voltage regulation. One is line regulation, load regulation, series and shunt regulation. So line regulation is a type of maintaining the output voltage where the input is fluctuation, and load regulation is maintaining the output remains constant even though load connected to the power supply changes. And third thing is that series voltage regulations. So in your series voltage regulation, the series element should be adjusted according to the output voltage. And the last one is your voltage shunt regulation, which employs a shunt element that is connected parallel and diverts the excess current through it. Okay. And this is the example of the linear regulation circuit. So there is any change in the input line does not affect the output voltage. Next, What is the working of voltage regulation? It has a sensor and error amplification and a control element and adjustment. So sensor senses which continuously monitor the output voltage, and error amplification is any deviation from reference voltage and the actual outputs are amplified to generate the error signal, and control elements is to eliminate the error signal, and adjustment is element the output voltage by varying the resistance of the switch state, it brings the voltage back to the desired level. Next, let us see about the properties and characteristics of voltage regulation. The main properties of voltage regulation is voltage tolerance and also load regulation and line regulation, which we saw in previous discussion. Ripple rejection, which means it filters the AC ripples and noise in the circuit, and transient response is how quickly the regulator responds to the sudden change of load or an input. And efficiency is something the percentage of the input converted to the output power. So the application of voltage regulations are power. It is mainly used in power supplies, automotive electronics, and telecommunications. These things are used in day-to-day life and medical devices, and also aerospace and industrial automation. So this is an example of series and shunt voltage regulation circuit. So here it is connected to the transistor. It acts as a voltage regulator, and this is a shunt connection. So it acts as another voltage regulator across the two resistors. And let us see the advantages and disadvantages. The advantage of voltage regulation is it protects the sensitive electronic elements and increase the lifespan of the electronic components, and also ensures the consistent performance of the equipments and reduces the risk and data loss. So let us see the disadvantages of voltage regulation, which means the costly to implement. Some application may introduce heat dissipation, and this is an example of voltage regulation. It's a Zener diode, how it acts as an voltage regulation prototype, and the formula for voltage regulation is where VR equal to load voltage minus full load voltage with respect to full load voltage into 100%. I hope you understand the session. Thank you.